Okay, next register, the 36867 register. Well, now what this register does is it tells the computer how many rows to put on the screen. Okay, but the number of rows actually occupy bits 2 to 6 in this register, which means the value that you want, you have to shift it left one bit before you put it in the register, which basically means you multiply it by 2. So okay, I'll show what we're doing here. Okay, line 10 sets the horizontal position of the screen. 620 poke 36865 sets the vertical position of the screen so that it's set in the corner, set up to the top left hand corner. Right, poke 36866 25 plus 128, that sets the number of columns to 25, which is the maximum on the NTSC. Okay, now it's business as usual. We take the value from the register 36867, put in a variable so we can restore it later. There you go. Clear screen and print the. Sorry, we start the count off. We're going to have 0 to 29 rows, because that's all. 29 is the maximum number of rows that you can get on the NTSC version. Okay, so then we clear the screen, print Cout again, which is the value that we're going to be putting into the, well, it's going to be the number of rows. Okay, then we poke 36867 2 times C, which shifts it to the left, so it occupies bits 2 to 6. Okay, obviously there's no point in putting in a value that'll make it higher than the number of the rows that the screen can actually display, so that's why we've capped it at 29. Right, okay, time delay, then we return the number of columns back to normal, so that's 22 columns, and then we return the value V back into the 36867 register, which will return the number of rows back to normal. Okay, I'll just run it, show you what happens. Okay, so the maximum screen size of the NTSC version of the VIC-20 is 25 columns by 29 rows. Okay, we'll run the PAL version of it. It's more or less exactly the same, except that the PAL version, it can have 28 rows, and it goes up to 35 columns. So 28 columns, 35 rows. Okay, otherwise it's just exactly the same program. Okay, so I'll just run the PAL version. Okay, I suppose I better explain the garbage that's coming onto the bottom of the screen. Okay, right. The screen starts at an address of 7680, and it's only 512 bytes long. Okay, the memory after the those 512 bytes doesn't actually exist, because that's where the memory expansion goes in there, the 8K memory expansion or something. So it ends at 8191, and that's where the screen ends. And then from 8192 onwards, there's nothing actually there. Well, this is the unexpanded version of the VIC-20, so that's why you're getting all that garbage. It's trying to take values from memory locations that are not there. Well, that's what I think, unless it wraps round, which I'm not entirely sure it doesn't. But if it does, it's just taking values from 7168 onwards. If it wraps round, it'll get to 8191 and then go to 7168. You probably don't understand what I'm saying there, but that's probably what it does if it wraps around. Okay, thank you for watching, and I'll see you in the next video. Okay, bye.